From the swirling storms on its surface to the crushing depths within, Jupiter is a planet of layers, pressure, and mystery. But what lies at its center? Does the gas giant have a solid core, or is its heart made of something stranger? In this episode of Infinity Beyond, we journey deep inside Jupiter to uncover what scientists believe lies beneath the clouds, through its atmosphere, and into its possible core. Jupiter is composed mostly of hydrogen, about 90%, and helium, around 10%, similar to the Sun. But unlike the Sun, Jupiter never became massive enough to ignite nuclear fusion. As we descend into Jupiter's layers, the pressure and temperature rise dramatically. Let's break it down. Layer 1. The atmosphere. Jupiter's upper atmosphere is composed of clouds of ammonia ice, ammonium hydrosulfide, and water, arranged in alternating zones and belts. These form the planet's striped appearance and drive powerful jet streams and storms like the Great Red Spot. Descending beneath the clouds, we encounter a region where the gas becomes denser and hotter. Temperatures exceed hundreds of degrees Celsius, and pressures reach dozens of Earth atmospheres. Layer 2. Liquid hydrogen. Deeper still, the hydrogen gas compresses into a liquid form. Jupiter has no solid surface. Instead, the transition from atmosphere to interior is gradual. Here, hydrogen behaves more like a dense metallic fluid. In fact, the boundary between gas and liquid isn't clearly defined. Layer 3. Metallic hydrogen. At about 1.4 million kilometers from the center, under pressures over 3 million times Earth's atmosphere, hydrogen becomes metallic. In this state, electrons move freely like in a metal, allowing this layer to conduct electricity and generate Jupiter's powerful magnetic field, the largest in the solar system. This metallic hydrogen layer may span over 40% of Jupiter's radius, and it's likely rotating differentially, meaning the inner regions spin at different rates than the outer layers. Deepest layer, the core, maybe. And finally, at the center of Jupiter lies the big question: is there a solid core? Earlier models suggested Jupiter formed around a rocky or icy core, roughly 10 to 20 times Earth's mass, which then accreted gas from the solar nebula. But new data from NASA's Juno spacecraft, which measures gravitational variations with extraordinary precision, suggests that the core may not be solid at all. Instead, Jupiter might have a diluted core, a large region where heavy elements are mixed with lighter elements like hydrogen and helium. This mixing could have occurred due to impacts during Jupiter's early formation, like a collision with a massive planetary embryo, disrupting a previously solid core. Juno's data reveals that heavy elements are spread out over a large volume, possibly up to half of Jupiter's radius. So instead of a compact rocky center, Jupiter may have a fuzzy, partially dissolved heart, a strange state of matter where rock, metal, and hydrogen coexist under immense pressure. This revelation has shaken planetary science. It means our models of gas giant formation may need to be updated. Jupiter may not be a perfect example of a two-layer planet, but something far more complex. Understanding Jupiter's interior also helps us study exoplanets, especially the many gas giants we've discovered orbiting distant stars. Do they all have cores? Are they diluted too? Some gas giants, like hot Jupiters, may be even puffier, with extended atmospheres and complex interiors. Jupiter serves as our baseline, the one we can study up close. There's also a cosmic connection. Jupiter's mass is just below the threshold needed to become a brown dwarf, a failed star. Had it formed just 80 times more massive, it could have ignited fusion and lit up as a second sun. So, the mystery of its core isn't just about structure, it's about Jupiter's identity, planet, or almost star. Future missions may reveal even more. Juno continues to map Jupiter's gravity and magnetic field with increasing detail. A follow-up mission, possibly with probes or orbiters closer to the center, could test the diluted core theory further. For now, Jupiter remains a world of speculation, a gas giant with a stormy surface, a liquid metal mantle, and perhaps a dissolving heart. In the next segment of Infinity Beyond, we'll look outward again, this time to Jupiter's gravitational reach. How far does it extend? And how does it shape the outer solar system, including asteroids, Trojans, and comets?